In this question we are given the differential equation dy over dx is equal to this ratio y squared over x minus 1, and we are being asked to sketch a slope field for a given differential equation at the 6 points that are indicated here. And so let's do that. Let's calculate first for the points x equal 2. So x equal 2 gives us x minus 1 equal to 1, which is our denominator will be 1, and so let's calculate numerator. Y equals 0. 0 over 1 gives us 0 slope, so this is 0 slope. 1 over 1 gives us slope of 1, so this is how the slope field will look like at that point. This is a slope 1. And then 2 squared over 1 gives us a slope 4, so this slope is kind of looks like this. And so going to the left at x equals 0, we see that the numerator is the same as in this case, but the denominator changes from positive 1 for these values to negative 1 here. So we have to have the opposite slope. Slope here is 0, so it remains 0. Slope here is 1, so it becomes negative 1. And here it becomes negative 4. So this is how it looks like. So here we are given that y equals f of x is a particular solution to this differential equation with the initial condition f of 2 equals 3. And we need to write an equation of the tangent line at x equal 2 and then use it to approximate f of at a point 2.1. So let's calculate the slope of this line, dy over dx. At the point we have point 2 and 3, so x equal 2 and y equals 3. Let's plug in 3 instead of y, 3 squared, and then 2 instead of x, 2 minus 1. This gives us 9. So the slope of the line is 9, and then the point through which it goes, the point x0, y0, is actually this point 2 and 3. So let's write a line that has a slope of m, 9, and goes through the point x0, y0, and the line is given by y minus y0 equals m x minus x0. That is the equation for the line with the slope m that goes through the point x0, y0. So y is equal to m is 9, x minus 2 plus y0 plus 3. So this is the equation, or in other words, we can rewrite as 9x minus 18 plus 3 minus 15. And so let's approximate f of 2.1. 2.1 will be equal to approximately 9 times 2.1 minus 15, which is 9 times 2.1 is 18.9 minus 15. This is equal to 3.9. So f of 2.1 is approximately equal to 3.9. So here we need to find the particular solution for this differential equation with the initial condition that we are given in the previous question. So let's use separation of variables, and so let's bring all dy with dx equals y squared over x minus 1. Let's bring all y's to one side and all x to the other side, and so we get dy over y squared equals dx over x minus 1. Then we integrate both sides. We get here negative 1 over y equals ln absolute value x minus 1, and don't forget plus c. Let's now find what c is by plugging in the initial condition. We get negative 1/3 equals ln of 2 minus 1, ln of 1 is 0, so 0 plus c. From here we can see that c is equal to negative 1/3. So let's write this down further, plugging in here negative 1 over y equals ln absolute value x minus 1 minus 1/3 multiplied by negative 1. 1 over y equals 1/3 minus ln absolute x minus 1. And so getting reciprocal, we'll get y equals 1 over 1/3 minus ln x minus 1 absolute value. And so this is our the particular solution to this differential equation. And note that we need to make sure that denominator is not equal to 0 and that ln is defined. So x is not equal to 1 and x is not such that negative 1/3 minus ln x minus 1 is equal to 0. Thank you, and I will see you in the next video.